Okay, I am making this video just for myself to review my intermediate algebra course, uh, just so I can look back on what it is I have to look back on, right? So the first thing that I have up was the first assignment, 2.5 in linear inequalities. I'm going to be solving them and explaining them because that'll help with my retention of memory. So hopefully I can learn something well. You can see I've already done a bunch of examples here. But actually, no, this is a different screen. Let's go to the other one. Or we can just open a new one. This is 2.5. Yeah, let's just open a new one. Okay, so the first question we have, x is less than -2. We have to graph this. I don't have a graph here, but I can't show you the computer screen at the same time, so I'm just going to show you, and then I'm going to write it in interval notation, right? So graph each inequality on the number line and write an interval notation. Okay, so this is the simplest question you're going to get. X, your inequality symbol, and then a number, and that's it. So pretty simple. For me, the first thing I like to do is, since I have a number line, first thing I like to do is I like to go to the number that's being specified. So in this case, it's -2, right? And then what's it called? I essentially almost always do it backwards, right? So based on the inequality symbol, we can see here, x is less than -2. So in this direction is less than, in this direction it's greater than, right? So it's pretty simple. If x is less than -2, then that means the x is over here, right? From -2. But keep in mind, the inequality symbol determines whether the actual number is included or not. So because it is less than and not equal to, it's only less than, you're going to put an open circle here. If it had been x is less than or equal to -2, you put a closed circle here, basically, right? So in this case, open circle because it's all the way up to -2, but not including that number. And the interval notation basically tells you is a way of writing down every possible solution, but without using the graph, right? So in this case, what's it called? You don't need to graph it to know interval notation, but as you'll see coming up, you do need to solve it. So in this case, the interval notation I'm going to do using the color purple is you look at the range, right? So we know x is less than negative. I gotta erase this up here. So we know x is less than -2. Uh, it doesn't stop anywhere before -2. All we know is that it's everything before -2. So the answer for this is going to be, if you can see here, everything before it, that's all the way to -infinity. Everything past it is positive infinity, but obviously we're going before -2. So the answer is going to be -infinity all the way to -2, not including it. So we're just going to write comma -2. And then the last step is you're going to either use parentheses or brackets. Now, in what case would you use parentheses or brackets? You use parentheses when you have the inequality less than or greater than. You use the brackets when it's less than or equal to or greater than or equal to, right? Whichever. Yeah. The way I like to remember it is the brackets kind of are more square, they're straighter, so I associate that with the straight line underneath the inequality symbol. So if you see that, that's immediately what comes to mind. So based on what I just said, negative infinity, because it never stops, it doesn't include a number. It's not like set, I guess is how you would describe it. It's always going to be a parenthesis. For negative infinity, positive infinity, no matter what, it is always going to be a parenthesis because it doesn't stop at a set number. It doesn't stop at a set number. And for -2, it is also going to be parentheses because while it does stop at -2, it is not equal to -2. So you would put a parentheses. Think of it as the brackets are more set in stone because it's square, it's very rigid, whereas the parentheses, they're curved because it's not, like I said, it's not rigid. It's including but not including. That's how I think of it. Next example is x is greater than or equal to 3.5. So pretty simple. Like I said, if you don't have a graph, you can always just draw it out and just write down the point that's being listed here, 3.5. So we read it, x is greater than 3.5. Okay, so we know greater than goes in this direction, right? So the x is going to be over here. We're going to do all of this. And then because we have the inequality symbol with the equal to, we can fill in 3.5 because it is including 3.5 as well. So in this case, the inequality solution would be starting from left to right, it would be 3.5 comma, and then we have positive infinity on this side. Positive infinity. Positive, any infinities are always parentheses, and because the 3.5 is being included, we put a bracket. That would be your interval notation. Next problem is x is less than or equal to 1 over 3. So now this one might be a little difficult if you know exactly actually no, this one's simple. The only issue here is that more likely than not, your graph that you've been given is not going to have a it's not going to have the like the decimals, the fractions, the spaces in between each number. So it's going to be very hard to tell where to put 1.3, right? Easiest thing to do is to just plug it in your calculator. What is 1 divided by 3? It's 0.3, right? And then you just start breaking it down. So we know this is 0.5, so 0.3 must be around here somewhere, right? And half of 5 is 2.5. So right here, so it means 3 is somewhere right here, right? So we can just assume it's like in this general area, right? This is 1 over 3. This is 1/3, right? You can also just cut the 1 into thirds, and then it'll be right here. Yep, this is 1 over third right over here. And pretty simple. The program should know what you're trying to put in. Hopefully you can type it in, but if not, if you're confident in the math, you can always just tell the professor, hey, this is what I wanted to put in. I'm showing that I did the work right, right? Pretty simple here. Same thing. X is less than 1 over 3. So x is all of this. And we have the inequality symbol with the equal sign. So it's equal to it as well. So then we fill in the circle. And for interval notation, this would be from negative infinity all the way to 1 over 3. Negative infinities are always parentheses. And because we are including the point, we put brackets. Very simple. Now, next question is going to be, okay, this one we're going to have something special, right? So this one is going to be -4 is less than or equal to x, which is less than or equal to 2. Now, when you look at this for the first time, it might be a little disorienting, but you just have to focus on one thing at a time, right? What I like to do is before even looking at it, I like to just go on the graph, right, and pick where the numbers are, right? So before I even look at this symbol or this symbol, the first thing I do is look at this number and this number, because everything else is going to be relative to those numbers, right? Everything is going to be relative to those numbers. So you write down the numbers where they are first, right? And then what I do is I decide, okay, so relative to, sorry, is -4 and 2 being included, right? And how we know that is the inequality symbol that they're next to. If it has this line here, if that means that it's equal to, that means yes, they are included, which means I can fill in this dot here. The dots are filled. Next one is we solve the direction for each one individually, right? So for 4, it says you just focus on this right here, what I've circled in. -4 is less than or equal to x. Or you can read it the other way. X is greater than or equal to -4. What does that mean? That means x, we already know, greater in this direction, is greater than or equal to -4. So we highlight all of this. It keeps going. Just pretend the 2 is not there, right? So everything in maroon, I should do blue for the next one. Yeah, everything in the maroon solves just this portion of the equation, right? Because x is greater than or equal to -4. And what we've highlighted is everything including -4 and above. So it's technically correct, but we've only done half of it. There's this half of the equation we also have to do. So for this one, you read it the same way. X is less than or equal to -2, or x is greater than or equal to x. So if x is less than or equal to 2, less than is in this direction, right? Which means it is going, I guess there's no way to make this pretty, but we can do like this, highlight all the way to the left, and then continue like this. So now you can see what satisfies what equation. You can see we'll highlight the blue for this section and then the red for this section, right? For the red side of the equation, you can see everything here satisfies it. Everything here and beyond is the answer to that. And for the blue side, everything here satisfies it and beyond, right? Here's the problem. You need to figure out what solves both. And as you can see here, both of the equations line up from here to here. Everything in the middle from -4 to -2 is the solution, which is what you would write. Okay? On a test, typically, you wouldn't do the arrows going in each direction. So you wouldn't go past this point, you wouldn't go past this point. You would only include what's going on here. Okay? The interval notation solution for this one. There's no negative infinities on this one. Like we said, the solution does not go past -4 and it does not go past 2, which means in this case, from left to right, the leftmost point would be -4, comma, the rightmost point would be 2. And because both points are being included, you bracket these two in, and there's your answer. -4, -2 in brackets. Okay? Next question is, I see it here, -1.5 is less than or equal to x, which is less than 2. So we'll pull out, draw a graph really quickly here, no lines, and then we just draw. -1.5 is right here, and then 2 is right over here somewhere. It doesn't have to be accurate, right? If you're drawing it like this, if you don't have a graph, you're only drawing the direction they're in, right? So it doesn't matter if I put 2 there, or if I put 2 here, or if I put 2 all the way over here, or if I put 2 right next to it. What's important is the direction they're going to, right? Because you can't, because like for the other question where we did 1.3, it's very difficult to accurately know exactly, is it here, is 1.3 here, is 1.3 here. You have to be perfect, and obviously if you're writing it, it's not perfect. So this drawing that I'm doing, it doesn't have to be accurate, mainly because I'm just showing you what it would look like. For this question, no matter how distant or close I draw the 2 points, this is what it's always going to look like. If I were to spread it out and if I were to elongate it, you would always have the overlapping points in between -4 and 2, right? So don't pay attention to that. Okay, first things first. We'll do the left side for blue. X is greater than or equal to -1.5. Okay, so X is greater than, we're going to the right, or equal to -1.5. All the way over here. And it is including it because it is equal to. So right here. Now, for the other one, X is less than, but not including 2. So, other way, we go this way. X is less than 2, it goes all the way over here. But it's not including. So what do we do here? Here, oh, we fill it in. So for the right side, we have a nice blue circle. For the left side, we have a nice blue circle. For the right side, we have an open circle. Now, we've graphed this. This is correct. The solution is in between them. So it's the same thing as the last question. Only difference is in this time, solving it left to right, you get the leftmost point is -1.5. The rightmost point is 2. Now, the leftmost point is equal to, so we put a bracket here. But the rightmost point, it does not include 2. So we put a parenthesis. And there you have that. For the next one, I want to solve something a little bit. There we go. This one's nice. For this one, we're going to do -4z is greater than 60. So now here, the first step you need to do is to isolate the z. You want this guy by itself, otherwise you can't really do it, right? First step to do is you would divide by -4. Why? Because you want to get the z by itself, as I just said. So when you divide by -4, the 4 up here cancels out. And then you're left with just the z. So z is greater than or equal to, and I don't remember what is 60 divided by -4. I'm bad at this simple stuff. Is -15. Now remember, when you're dealing with inequalities and you're dividing or multiplying by a negative number, the inequality symbol here is going to flip to the other side. So instead of z is greater than or equal to -15, you would write z is less than or equal to -15. Always remember that, whether you're dividing or multiplying by a negative number here, you always flip the inequality symbol. Very important. Always keep that in mind. So in this case, the answer is going to be z is less than or equal to -15. -15 is right here. Z is all of this. And then red dot, inequality solution is from -infinity, parenthesis, all the way to -15, brackets. Next question, we'll move down here. Next question is going to be z over -5 is less than or equal to 10. Same thing as the other one, we want to get the z by itself, but this time we have a fraction to deal with. So, yeah, so the first step is going to be here is you want to get the denominator out of there so that it's not a fraction anymore. Simple thing to do here, you would just multiply by -5 both sides. And that would cancel out these guys right here, leaving you with z is less than or equal to -50. Remember that when you multiply or divide by a negative number, the inequality switches. So in this case, we get z is greater than or equal to -50. Putting that on the graph, you get -50 right here. z is greater than, which means we go all of this. And then the inequality solution is going to be from negative 50 all the way to positive infinity. Positive infinity has the parentheses, negative 50 has the bracket. There's the answer for that one. Next one. I'm going to look for a good question. Okay. Next question. We have 2k is greater than or equal to 9k is negative 42, right? So what do we do here? Here, it's not like the other questions where we have to isolate the z. Here, we have to bring them together first. That is our first step. We can't isolate the k's here because they're not by themselves. The k's are in one side and the other side of the inequality. So the first step is to combine like terms. You want to bring it to the other side. And by doing that, and to do that, we do minus 9k minus 9k. Well, you do the one side, you do the other. On the right side, that cancels out, and that leaves you with negative 7k is greater than or equal to negative 42. In this case, the inequality doesn't switch because we're not dividing or multiplying by a negative number. We're just adding and subtracting, which would not change it. Now, this case, next step, we divide by a negative 7, which cancels out this negative 7 and flips the inequality symbol, leaving us with k is less than or equal to, and this should be negative 42 divided by 6. Sorry, negative 40, okay, no, it's 6, is less than or equal to 6. On a graph line over at 6, less than, right? So all of this, and then we fill in the circle. Inequality notation would be from negative infinity, parenthesis, all the way to 6, brackets. Simple. Yeah, next question. Okay, here's the next question. It's going to be 12t plus 2t plus 4 is greater than 5t minus 64. Okay, so now similar to the last one, we're going to have t on both sides of the inequality, but there's an extra step. The extra step being the parentheses. We have to distribute first, right? So the first step we're going to do is distribute the 2 with the t and the 4, which would get us 12t. 2 times t is 2t, and then 2 times 4 is 8. Putting everything back in, we get this. Now, we combine like terms. So on this side, on the left side, we have 12t and 2t, which combine to 14t, then add everything else back in. 14t plus 8 is greater than 5t minus 64. Now, we can start moving everything so that it's in the right place. Minus 8 on this side, minus 8 on this side. That'll cancel this out and leave you with 14t is greater than 15t minus, and I'm bad at simple numbers like this, negative 64 minus 8 is negative 72. Negative 72. Following that, we subtract the 5t from this side so that we can get all the t's on the same side. That'll get us on this side 9t is greater than negative 72. Then we divide both sides by 9. That'll cancel out the 9 right here, leaving us with t. T is greater than negative 72 divided by 9 is negative 8. That is your number. Then you just put it on the number line, negative 8. T is greater than this number, so we just go all the way over this, including that, and then it is not including -8, so we put an open circle here. The inequalities notation solution would be parentheses -8, then all the way to positive infinity, parentheses, is your solution for that. Next question. Here we have a very interesting one. This is 8y minus 2 parentheses 16 minus y parentheses is greater than or equal to 8 parentheses y minus 4 parentheses plus 2y. So we've got twice the amount of parentheses here. Now, whenever something like this happens and you have a lot on your plate, don't get overwhelmed. Just do what you can. Solve it as easily as you can. Okay? Trust your math. Don't overthink it. So we're going to distribute these guys. Then we're also going to distribute these guys. Okay? So 8y negative 2 times 16 is negative 32. Negative 2 times negative y is positive 2y, which is all greater than or equal to 8 times y is 8y, and 8 times negative 4 is negative 32 plus 2y. Here, now we can combine like terms. These guys combine and these guys combine. When you put 8y and 2y together, you get 10y. Adding the negative 32 is greater than or equal to, then 8y plus 2y is 10y, and then bring down that negative 32. Now, here you can already see what your solution is going to be. If you just look at it, you can tell, if you're paying attention, it is the exact same thing, right? Here you would already deduce what your solution is, but we're going to continue so that it's easier, and I'll explain to you why here's where you could, in theory, stop if you know what you're doing. Once you practice enough, you'll know. So now you continue to get negative 10y, negative 10y. That'll cancel out this guy, and that'll cancel out that guy. Now you're left with negative 32 is greater than or equal to negative 32. Then you can add negative 32 to both sides, which will cancel out this guy and this guy, leaving you with 0 is greater than or equal to 0. Now, what do you do here, right? How would you graph this? If I had a graph out here and I had at 0, well, it's not less than, right? And 0 can't be greater than 0, but it is equal to 0. That's your answer. When you get something like this, where it's the exact same number on both sides and it has the equal included, that means that your all real numbers is the solution. So for inequality notation, so for this question, you would put, you would, on the graph, you would put this, but your answer might be a little confusing compared to the graph, is going to be from negative infinity all the way to positive infinity. You include every number, right? That's your answer. Next question. This one is one of those questions where if you look at it too long, you might get overwhelmed. You really just have to trust the process and stick to your math, be confident, and use what you've learned. So the question is 3 over 4x minus 2 over 3, parentheses, x minus 3 is less than or equal to 1 over 12, parentheses, x plus 24. Let me pause it really quickly. Okay, if you look at this question, you're like, I don't know where to start. Start with what you did in the last question. Typically is the most helpful, right? So what do we do in the last question? The last question, well, we distributed, which is what we're going to do first here. A calculator will help you here, but for these, you can kind of do in your head, or at least I can. 3 over 4x, and then negative 2 over 3 times x is negative 2 over 3x. Negative 2 over 3 times negative 3, think about it like this, right? If you multiply negative 2 over 3 by negative 3, what does that do? It cancels this guy out and leaves the 2. So that's what you would do here. Here you would do plus 2. And then the inequality symbol is less than or equal to negative 1 over 12 times x is, just 1 over 12 times x is 1 over 12x. 1 over 12 plus 24 is 2. Simple. Next step, we're going to try to move everything together. So here, you would subtract 2 from both sides. That cancels them out. Now you're left with 3 over 4x minus 2 over 3x is less than or equal to 1 over 12x. Okay. We want to move the we want everything on the same side, right? So we're just going to simply subtract this from both sides so that we can move it over. That'll cancel out these guys, and that'll leave us with 3 over 4x minus 2 over 3x minus 1 over 12x is less than or equal to 0. Okay, so this is where I typically get confused a lot on tests, because by heart it's not natural to me to add or multiply or subtract fractions, right? It's still something I'm not easy with. But what you do here is you want to find the least common denominator. You want to make sure, in order to combine all of these guys, they all have to have the same denominator. One has 4, one has 3, one has 12. They all need to be the same in order to combine. And once we can combine them, we can continue on with the next step. How do you find the least common denominator? The easiest way, if we have short numbers like this, is how do I say? Is you just write each number down, and then you keep adding it to itself. So 4 plus 4 is what? It's 8. 8 plus 4 is what? 12. 12 plus what? 4 is what? Is 16. Next one. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. And then 12 plus 12 is 24. We can stop there. You are looking for the same number in all of them. You are looking for the least common number. And if you look very quickly, every number here has 12 first, is the first number they all have in common. So that is what you're going to do. You're going to take, there we go. You're going to take 12 and have that be your least common denominator. So now what do you do with that piece of information, right? Well, each fraction has a different denominator. You need them all to be the same. So what you do is you multiply each fraction by a number that will get the denominator to what you want it to be. So in this case, you would multiply this first one. 4 times 3 would get you 12. 3 times 4 would get you 12. And 12 times 1 would get you 12, which you don't really have to do that, right? And when you multiply them, you would get, you multiply the numerator and the denominator by 3, by the way. So 3 times 3 is 9. 4 times 3 is 12, and then the x. Negative 2 over 3x. Just 2 times 4 is 8. 3 times 4 is 12x. And then the negative 1 over 12, I'm getting a lot of Discord messages. Negative 1 over 12x is less than, I'm gonna have to mute this in a second if they keep sending messages. Okay, now that they all have a common denominator, you can subtract them, right? Or you can combine them, right? So these guys, negative 8 over 12 and then negative 1 over 12 will get you what? That'll get you negative 9 over 12x. And then you add the other 9 over 12x is less than or equal to 0. These guys cancel each other out. And then you're left with what? you're left with 0 is less than or equal to 0. Same as the other time. In this case, once again, because of that, the answer is going to be negative infinity to positive infinity is your answer. Next question, we are going to do, this one's a little special. So this one's going to be 5 over 6a minus 1 over 4a is greater than 7 over 12a plus 2 over 3. So in this case, notice that we have 3 with a's and 1 that doesn't. So this is going to be a little different from the last one. But the first step you would do is move everything together. So you're going to subtract the negative 7 over 12a from both sides, right? That cancels out these guys. And on the left side, you're left with 5 over 6a minus 1 over 4a minus 7 over 12a is greater than 2 over 3. Next step is the same thing we did in the last one. If these all had the same denominator, we wouldn't have to find the lowest common denominator. But because they don't, we do. So if you notice here, all these numbers, same as the last question, the first number they add up with each other is up to 12, right? 4 times 3 gets you 12, 6 times 2 gets you 12, and 12 times 1 gets you 12. Then you multiply the numbers by what you need to get 12. You multiply this guy by 2, you multiply this guy by 3. 5 times 2, 10. 6 times 2, 12. Then the a, 1 times 3, 3. 3 times 4, 12. And the a, and then negative 7 over 12a is greater than 2 over 3. Okay, next step is to solve it. So these guys combine, and that gets you negative 10 over 12a, and then you put the other 10 over 12a over here, is all greater than or equal to 2 over 3. These guys, if you notice, cancel out. So that leaves you with 0 is greater than 2 over 3. Now take a second and read what you just wrote. 0 is greater than something that isn't a negative or a 0. So that doesn't work. That is a contradiction, which is your answer. Your answer is that there are no solutions. It is a contradiction. This question does not have an answer. Next question. Okay, next question right here. Let me pause. All right, so the next question is 46q minus 2 parentheses 7 minus 7q parentheses is greater than 4 parentheses 15q plus 3. A lot of distribution that we're going to do here in a second, okay? So for this question, you distribute these guys and then you distribute these guys. This is your first step. 46q minus, and then negative 2 times 7 is negative 14. Then negative 2 times negative 7q is positive 14q is greater than 4 times 15 is 60q, sorry. And then 4 times 3 is 12. Now, next step, combine like terms. These guys combine. That gets you 60q minus 14 is greater than 60q plus 12. Next step is what do we do first? We can just move these guys, negative 60q, negative 60q, which cancels u. I'll use the dark red, cancels u and cancels u, leaves you with negative 14 is greater than 12. We already know that's not the answer and what's going on here, but we can just continue. Plus 14 plus 14, that cancels out. That leaves you with 0 is greater than 26. What is this? This is a contradiction. This has no solutions. That is your answer for this question. Next one we're going to do is a fraction. We're going to do negative 11 over 4z. Oh, well, I'll do 11 over 4 negative z like that. Is greater than or equal to negative 33 over 20. So now, this is the first time I think this is the first question we've done with two fractions, one on each side. Yeah, just one on each side. Okay, so first step to do here is you want to start limiting the amount of fractions you have. So the first step you do is you can multiply this side by 4, which cancels out these guys on the bottom. That leaves you with negative 11z is greater than or equal to, and then for this guy, when you're multiplying one number by a fraction, you can just multiply the top number. So 33 times 4 is 132. So negative 132 over 20. So great. First step got us down to only one fraction, which is good. Now we do the same thing but in reverse. So now we can actually, you could multiply by 20 here, but you'd get a bunch of big numbers. The simplest thing to do here is to minimize the fraction. So we have big numbers here that we can break lower. So the first thing to do is see what number can I multiply them both by. So 20 is a very easy number to figure that out with. Can you divide 132 by 20? No, you get 6.6. It has to be a whole number. Can you multiply 20 can be divided by 10 evenly. Can you multiply 132 by 10? No, you can't. You get 13.2. The 20 can be divided by 5 evenly, right? So can you divide 132 divided by 5? No, 26.4. 20 can also be divided by 4 evenly. Can you divide 132 divided by 4? Is 33. So that works. So then you can take both those numbers. They can both be divided evenly by 4 for 20, that would be 5. And for 132, that'd be 33. So you get negative 33, 5, which you can then bring over here. Negative 11z greater than or equal to negative 33 over 5. Boom. Okay, next step, you want to get rid of the fraction. So now that we have smaller numbers, we're not multiplying by negative 20 on both sides. We can now multiply by 5 and get the same result. That's why we do it. It makes it easier. Multiply both sides by 5. That'll cancel out this 5 over here. And 5 times negative 11z is negative 55z is greater than or equal to negative 33. Now look at that. By doing those two steps, multiplying the numbers by each other, we have removed all the fractions. So now things get a little easier. Now we can divide the left side by negative 55. So you'd have negative 55 over here. That'll cancel this guy out, and it'll flip him around. That'll leave us with z is less than or equal to 33 over 55. But like the previous time, these numbers are way too big. While it's technically, I guess, correct if you've done the math right, it's not simplified, so it will be marked as wrong. So what number can we divide? What's the biggest number we can divide both of these numbers evenly into? And just by looking at them, the easiest number that comes to mind is 11. You divide both of these guys by 11, you get 3 over 5, which is your simplified and true answer. C is less than or equal to 3 over 5 is your answer. And because we're doing it on a graph, once again, that is technically right, but you cannot put input, or at least for mine, you need to put it into a decimal form because 3 divided by 5 is 0.6. That is the actual answer on the graph. That is most likely the format they're going to want it in. So you're just going to have to do the math. It doesn't matter if it comes out a decimal because you've got your final answer, right? So could you do that anywhere else, right? If we did it right here, 33 divided by 55, once again, that'll give you 0.6. But I like to go the extra mile just because it's good practice to remember this, to remember, hey, sometimes these numbers can be brought lower because sometimes you are going to have to bring it lower. So it's a good step to remember that. And while ultimately you can skip this and this step, you got to ask yourself, how, like, would I benefit from this practice? Next question is, okay, we're going to do y over 16 is greater than or equal to -9. First step here, we're going to multiply this guy by 16 on both sides. That's going to cancel out this 16 and leave us with y is greater than or equal to, and then -9 times 16 is -144. That's your answer. It looks easy because it is easy. Don't be surprised by the occasional easy questions. Sometimes they throw them in there to just confuse you. And definitely don't second guess yourself. Second guessing yourself is probably the worst thing you could do. Too much second guessing yourself, and you'll start questioning the things you got right, which never, obviously, is helpful. You can see here we didn't do any math, and even though it looks suspiciously easy compared to what we've been doing, it was right. So trust the math that you're doing. Understand that you're practicing, you're learning, and that you are growing your skill. If you question yourself too much, you're going to take 2 steps backward, 1 step forward, right? Inequality notation solution for this one is going to be -144, this in brackets, and then positive infinity, that in parentheses. Very simple. Okay, so for this next one, we have something different from what we've been doing. We have a word problem. Here we have, we'll do 9 less than z is at least 25. I'm only going to do one of this one. So what I like to do here is ignore this last part first, because that's usually the easiest part to solve. If you get confused by math problems, you want to focus on this first. And what I do this is I read it backwards. Not 9 less than z. Z is less than 9, right? Or I say it backwards, right? I write it backwards. 9 less than z. What I write is I write it backwards, but I read it forwards. So 9 less than z. And there you have it. Rather than you have to figure out, okay, z, just for me, this is how I do it. 9 less than z. And then now we do is at least 25. So what I do is I usually just write the number here for space for whatever the inequality is going to be. And then that way I can see it visually what it's going to be. So here you just have to ask yourself, is at least 25, right? So when someone asks you, like, can you bring at least 5 apples from the groceries? They're not saying bring 4, bring 3, bring 2. They're saying bring 5 or more. So whatever you bring has to be 5 or more, right? So in this question, it's saying this section, all of this, has to be at least 25 or more, right? So this has to be greater than 25, but it can be equal to. And there you have it. So now what the word problems are doing is putting it into word format and giving you the pieces to the puzzle. You have to put it together, and if you get it right, and now you can solve it. So best believe you read it correctly, because if you read it incorrectly, the math you do here will be wrong. Well, technically won't be wrong, but you'll get the answer right. If we had done it the other way around and we had written 9 for whatever reason, we wrote 9 minus z and then solve for this, the math would technically be correct, but because we read this wrong, it'd be wrong. We're writing something differently, regardless of the fact that we're doing the math correctly, right? So now, always double check here, because while the math is always, if you know what you're doing with the math, it is always going to look right, but it will always be wrong. So this step you have to make sure, just reread it, make sure it works. First step we're gonna do is just solve like anything we did everywhere else before, and then we get something simple. Z greater than or equal to 34. That's your answer. And you would just draw that 30, no, that's a 34. 34. Z is greater than, so all of this, and then a circle. Inequality notation solution is going to be bracket 34 to infinity. And that'll be pretty much everything for this section. This is 2.5. There's word problems here, but I can't show you the word problems. So you're cooked, really, I'm sorry. But yeah, we've done 90% of what's on this. So yeah, hope this is helpful later.